let's practice sketching some parametric equations. So the simple, we did a very rudimentary example. Let's do one that's a little less rudimentary. What you want to do anytime you have parametric equations is you want to make sure, A, that you've backed up far enough in your t values, or your, in this case, theta values, that you don't miss something. Because if you start at like t equals 0 even, sometimes you might miss it. So a lot of times it's useful to start with t kind of backwards. In this particular case, I don't know that you're going to have to do that. You definitely have to watch out for things like t can't equal 4, because if it equals 4, it's going to go boom, it's going to blow up. So we do need to be careful about that. But other than that, we'll try some, and if we need to add some more, we're going to add some more. That's just part of the process. So we're going to say, all right, t is, let's try -2, -1, 0, 1, 2, 3. Now we're also going to do something else. I'm going to do like 3.5. You don't have to do whole numbers here, but I'm going to do 3.5, and I'm going to do 4.5, and I'm going to do 5. And the reason I want to do this is because I want to get near 4, but I don't want to hit 4, right? So you could obviously do things like limits here, but anyway. So if I do t is -2, then x is -6, -5, -4, -3, -2, -1, -1/2, +1/2, and 1. So we might need some more just so we can get x values that are positive, but maybe not. And then for the y values, we have to think about this. So -2 divided by -6, that's on 1/3. So -1 divided by -5 is 1/5. This is going to be 0. 1 over that is -1/3. 2 is going to be -1. 3 is going to be -3. -3.5. So let's see, it's going to be 3.5 divided by -0.5. So it's going to be -7. Now 4.5 is going to be 4.5 over 1/2, so that's 9. And 5 is going to be 5 over 1, so that's 5. So it's probably not actually enough to tell you what you need, but let's try it. So now we have -6 and 1/3, -5 and 1/5, -4 and 0. So -3 is -1/3, -2 is -1, -1, -3, and then -1/2, -7. So if I'm drawing this, I'm thinking it looks kind of like this. But I also know that I can't have, like if I had t equals 4, this would be 0. This would be 0. So I know that this is like a no-go zone here. So I think it's going to look like that. Now on the other side, when I get 1/2 and 9. So I get like all the way up here. And then I get 1 and 5. And that's really not enough. So I need to do some more. I need to do 6, 7, 8, 9. So that's going to be 2, 3, 4, 5. And then when t is 6, it's 6 over 2, which is 3. 7 over 3, which is 7/3. 8 over 4, which is 2. 9 over 5. That's still not very good, right? It's still kind of tough. So now we have 1, 5. We have 2, 3. We have 3 and 7/3. 4 and 2. 5 and 9/5. So in this case, what you might want to do actually, I mean, you could continue to plot, but if you take a limit here, what happens as t goes to infinity? If I take t to infinity here, that's actually going to come out to be 1, right? It's going to be infinity over infinity. You take L'Hopital's rule, it'd be 1 over 1. So we actually end up with an asymptote of 1. So we have that. Now that's pretty nasty, right? That was pretty not fun. And we want to mark the orientation. The orientation so as we move along, we go along that path. That's how we mark the orientation. So hopefully that's maybe that's kind of hard for me to see in my little preview that I'm looking at. So hopefully you can see that. I'll try to make these arrows a little bigger next time. So that's kind of how you have to do it. Now you don't always you get lucky. Sometimes you don't, But anyway, that was harder than I would have expected looking at it. Now over here we have thetas. So we do the same thing, we just have theta instead of a t. So don't get freaked out. It's just a different parameter. So this is really a function of the angle. So the nice part is that these are sine and cosine functions. So it doesn't really matter what theta we start at because it's going to have a period. What we know is that by the time theta hits 2 pi, these things are going to turn over back to where they were before. So we don't have to go very far. We can say, all right, I'm going to do 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4. And that'll cover all my pi over 4s. If that's not enough information, we'll continue on. So when theta is 0, cosine of 0 is 1. So that gives me a 2 here. Sine of 0 is 0. Cosine of pi over 4 is square root of 2 over 2 times 2, so that gives me square root of 2. And this is also square root of 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So in the 3 pi over 4 case, cosine is negative, but sine is positive. In pi case, cosine of pi is negative 1, but sine of pi is 0. In the 5 pi over 4 case, they're both negative. In the 3 pi over 2 case, cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is actually negative 1. In the 7 pi over 2 cosine, or 7 pi over 4, cosine is positive. Sine is negative. Okay, so now we have our plots. We have the point 2, 0. Then square root of 2, square root of 2, which is like here. And then 0, 2, and then here, which that's negative square root of 2, square root of 2, negative 2, 0. So then here, here, and here. So hopefully you can see that's the rate that we're going. So we are now moving in a circular fashion. It's not the best circle I've ever drawn, but it's not the worst. And our orientation seems to be anti-clock or counterclockwise, and that's how we would note that. And that's kind of the basics of what you want to do here. You want to plot the thing out and just sort of examine how it behaves.